the idea up there on Twitter about a Hugging Face course with the fastai bent, and I probably got the most responses out of anything I've ever put on Twitter. And in addition to myself, I'm glad to also be joined by the Avengers. I don't think I could be Captain America because I haven't really been lifting the weight, so that's probably Zach. But hopefully, I can at least be Thor, or at worst, the Hulk. So there's a lot of people on this call. So if you have questions as we go through the material today, just feel free to put them on there. I'm going to stop periodically. Sanyam's going to be answering questions, as well as hopefully other folks. And if there's any outstanding questions, we'll answer them as we hit every individual section. And also thanks to the folks at Weights and Biases, Andrea and Morgan, who I also know from the fastai community. I appreciate you all handling all the logistics and whatnot. So let's begin. So this week we'll start by looking at section 0 and 1, and section 0 is pretty simple. That's the setup. And really our goal here is to make sure that you can go through and run the examples in Colab. And then the section 1 is probably going to be the least fast AI-ish part of the study group, since it's kind of just covering the basics of how the transformer architecture works and what type of NLP tasks it's suited for and how they work. And so we're going to look at their high-level API, which is the pipeline API. And we'll see how we can actually just start using models in Hugging Face within a few lines of code with raw text to get predictions for a variety of tasks. And then next week, we'll actually spend some time looking at Blur's high-level API. And I cross it out because it's actually more for training than just inference, whereas the pipeline API, we're just looking at inference. So we're looking at pre-trained models that, or not pre-trained models, but models that folks have put on the Model Hub or Hugging Face has put up there, or models that you've trained, how you can use the pipeline API to do inference on that. And then we'll also have some resources and homework. The homework is optional, but I hope you'll be excited to do it anyways. I guarantee if you do the homework, it will help you understand so much more about how all the transformers work. And there's a lot of them. So when you go to the Hugging Face documentation, you've probably seen it used to be like maybe 10 transformer architectures. Now I don't even know how many are on there. It's like 50 or it's just like an endless list you scroll through. And understanding the transformer architecture, the core architecture that all these things were based on, will help you know which ones to at least narrow your choices down depending on your task and how things work. So we'll look at some homework there, and hopefully everybody will do it. First off, some resources. If you're here, you've obviously found resource number 1, but if you want to share that with folks who may want to join in over the next 4 weeks, that's the link to the registration page for the study group. We also have a study group Discord that's hosted by fastai, and so the link's here. In addition, I will share my slide deck, so don't feel the need to write all this stuff down real quickly. This will be shared, and folks will be able to have these links at their disposal. Next, we have fastai resources. And so I think people in the study group are at a variety of levels. Some have been doing fastai for far too long, like myself, ever since it was taught in Theano, believe it or not. And others are new to the course and are maybe doing the reading study group with Aman in the Weights and Biases Fast Books reading and study group. But these are some really great resources. It's first the course, and it's free, it's online, absolutely the best deep learning course. If you want to get involved and learn how to actually apply deep learning and how it works and how to build models, how to put them in production, I think the fastai course is the best. And also a tremendous community. And a testament to that are a lot of the folks that are on this call. Most of them, probably all of them, except for Sanya, because of the coffee comment, are probably smarter than me. And so a lot of great folks on here who have become exceptional machine learning and deep learning practitioners through the course over the last few years. Second is the Walk with Fast AI course that Zach has up there, and that's all free as well. And that's a great compendium to the course, and it answers a lot of questions and expands on some ideas that come up in the course but aren't necessarily covered in there. So that's a great resource as well. And then, of course, the Fast Book and the Fast Book Reading Group. So you can get this book online. You can purchase the hard copy, or Jeremy and Sylvan have made it available for free via Jupyter Notebooks. And if you just do a Google search, you should be able to find that. And then, of course, there's the Fast Book Reading Group. And I participated, I've been on there a few times just watching and observing, and that's actually a great resource. Alman does a really great job of going through all the chapters. And I think his goal is to go through the entire book. So check that out. In terms of fastai and Hugging Face libraries, if there's more, let us know and we'll add those. But these are the three that I'm familiar with. The first is Adapt NLP, and that's by Novetta, and that's what Zach Mueller is heading up. And then really, I think it really wasn't me that started with Blur. It's the Fast Hugs by Morgan. He was like the first one that I think put Fast Hugs up there. Great name, by the way. And I think Ardo now is heading that up. But Fast Hugs is kind of like, at least for me, was my initial inspiration for like, oh yeah, we can actually do something with Fast AI, and not just with sequence classification, which is where I think Fast Hugs was focused on initially, but actually started applying it to the other NLP tasks. So summarization, translation, everything. And so third is Blur. That's the library I created. I'm still working on it. I think it's like a version 0.26 or something. I don't even know. But speaking for myself, I would love to get more people involved. So check it out. There's documentation, the code's there. You can email me. I would love to get people involved in helping build this out. And that would be a great way to also develop your understanding and learning of how transformers work and how Fast AI works. Then ML and data science in general, we got the Chai Time Data Science podcast by Sanyam. And one of these days, we maybe have the dark roasted coffee time data science podcast, but for right now, it's Chai. So, but check that out. And Sanyam interviews tons of people in the community, and they're really great insights into not only what's happening in the realm of machine learning, but how people got started, how they developed their careers and whatnot. So that's a great podcast. And then, of course, we got Weights and Biases, who are hosting this. And for all things in terms of tracking your machine learning projects and whatnot, it's super easy to integrate their product into any type of machine learning or deep learning project you have. And they got tons of like free content and whatnot. And there's folks on this call as well that if you want to get more information, could provide that for you. So let's get started. So number one, setting up your environment. You'll notice that when you go through the course, there's a collab button at the top of a lot of the course pages. And you should be able to open that or click on that, and it will open that page with the code in collab. But I noticed that sometimes it's missing dependencies. And so if you want things to work, this is the right pip install right here that you want to include. Is you want to do transformers with sentence piece. I think by default, it just does pip install transformers, and then some of the examples will break. So for Colab, make sure that you use this pip install, and we'll actually look at a notebook. You can see how I set it up. And if you're going the local virtual environment front, I typically use Conda or Mini Conda, and then Jeremy Howard recommended to several of us a product called Mamba that just makes Conda work fast. So I've been using Mamba, and essentially it's just a fill-in for Conda. So wherever you put Conda install, you put Mamba install, and it is a lot faster. So check out those resources if you want to go the local route. And then also FastAI has a Conda channel for installing all things FastAI. And so the link is right here. I've been using it for Blur, and it does make things simple along with Mamba and really fast to keep updated with everything. And I'll also mention, because there's a lot of discussion about using poetry to manage your environments. I've never used it. So if there's folks that are using poetry that like to share example with the group, I know personally, I would love to see a poetry configuration set up with fastai and Hugging Face to see how that works and the benefits. So I hear a lot about it, but don't know anything from personal experience. Any questions coming up yet, Sanyam?
No, I don't see any questions. There was one broadly that asks you, should they be doing the Hugging Face API course, or is it better to start from scratch?
The Hugging Face course, or
Hugging Face course, or just learn from scratch? I think that's the question.
I think the Hugging Face course is worth doing, and maybe even for this, because especially as we get into week 3, we're going to be looking at more fastai code. So we're going to deviate from the course content. So I think it's actually good if folks can do the course during the week, at least watch the videos and do a cursory reading so that they have the background for what we're going to be covering in the study group.
Yep, no other questions. That's it.
All right. So essentially the course that Hugging Face has put on, it's really great. It has a lot of great folks with video content. They're actually doing some study groups as well. And the initial course, they've only introduced this part, the introduction. And so there's 4 sections on transformer models, using transformers, fine tuning, and sharing models and tokenizers. This is the only part of the course that is out now. I think the diving in portion comes in the fall, and the advance is either late this year or early next year. But we're going to see with this first 4-week session, there's so much that you could actually get going in terms of building transformers, using them in production, and also sharing them with the community through the Hugging Face Hub. And in particular, over the next few weeks, we're going to show how to actually fine tune these models using Blur, Adapt NLP, Fast Hugs, and then how to take those models and actually share them on the hub, create a model cart, all that stuff. So I'm hoping by week 4, a lot of folks are training models and sharing them on the hub and contributing to the community. It should be pretty straightforward. All right, so the first section is we got natural language processing. Essentially, NLP is a field of linguistics and machine learning focused on understanding everything related to human language. And this is really a tough problem in terms of machine learning because ML models only understand numbers. So how do we use numbers to create some type of system that can understand sentiment or toxicity or summarize or answer questions? And so it's a really tough area in machine learning. And some of the common tasks that we'll be going through over the next 4 weeks are sequence classification tasks. So that's where we're looking at whole documents, for example, movie reviews or comments, for example, and we're trying to classify them, things like sentiment, whether it's spam, whether it's grammatically correct, whether 2 sentences are logically related. And we're also talking about multi-label classification problems. So on Kaggle, there's a jigsaw toxicity challenge where there's, I think, 7 or 8 levels of toxicity. And you want to predict for every document whether it actually has none, 1, or more of those labels associated or should be associated with it. Another task that's common is token classification. And here we're talking about things like named entity recognition, where we got a text document and we want to find where are all the people's names mentioned, where are all the geographical locations mentioned, where are organizations mentioned. We want to identify those entities. So we're looking there to identify and classify tokens. Also, we have text generation, which is you complete you have a prompt you start out with, and then it generates a bunch of text that sometimes makes sense and sometimes doesn't. And a great example of this is the new GitHub Autopilot, which is actually doing this for code. And it's like scary how good it is. Really impressive stuff. And so that's looking there at text generation. And then another one that we'll also look at is extractive question and answering. And essentially what you do is you feed the model a context, like an article and a question that article has somewhere in there, the actual answer, and you want the model to provide that segment of text in the article or context that is the correct answer. So these are really kind of common tasks, and deep learning is where the state of the art is. And there's a lot you can just accomplish in terms of these things using the transformer or the transformers library from Hugging Face. So the transformers library provides functionality to create and use these shared models. The model hub contains thousands of pre-trained models that folks can download and use. We'll take a look at that. It's got all kinds of filters. You can filter by task, by language, etc. And then right now, we'll take a look at the pipeline API. And essentially, the pipeline API connects a model with the necessary pre-processing and post-processing steps, allowing us to directly input any text and get an intelligible answer. And so what the pipeline does is it's going to take the raw text, it's going to do a process of tokenization that actually includes tokenization, which is splitting the text into individual words, and numericalization, which is for each of those words, it has a vocab, which is essentially a lookup list. So it will convert every one of those words to a ID in that vocab list. And that is the numerical representation that we start with to feed the text into our models. And we'll look at how that works. Then it runs it through the those post-processed inputs into the model. And then afterwards, we get predictions. It cleans those up so that they actually look understandable to us humans. So we'll take a look at how that works right now. And hopefully this is big enough for folks. If not, let me know. I can make my screen bigger. So in terms of installing in Colab, if you put this little dash QQ, you won't get all that output that usually just clutters your screen. So here I'm actually installing both the transformers library with sentence piece and also the datasets library. And then I'm going to import the transformers pipeline. And we were talking a moment ago about tokenization. So I wanted to just go over that real briefly, what that looks like. So in the first example up here, I'm going to use the BERT tokenizer. And I just wanted to show you that if you print out the type, I see BERT tokenizer, right? And if I print tokenizer, you can actually see there's some really helpful information that Hugging Face has when you look at the string representation of that object, such as the vocab, which is how many tokens are in there, the max length, etc. But the recommended way to actually build Hugging Face objects, including the tokenizer, is by using these auto models. So there's auto tokenizer, there's auto config, then there's auto model, there's auto model for task, and that's what they recommend. And it will automatically infer the correct objects based on the model name or path that you type in here. So you can see this code right here is essentially the same, except I'm using auto tokenizer, and it knows to create a BERT tokenizer, and you can see it's the same information as before. So when you're working with Hugging Face, you typically want to use these auto tokenizer, auto config, auto model for when building your Hugging Face objects. So as I said, when the tokenizer runs on raw text, it actually is doing more than tokenization. It's also doing numericalization, which is converting each of the tokens to an ID that can be looked up in a vocab. And so here I am tokenizing this text. And if we look at the type of inputs, it's a type batch encoding. We can convert that to a dictionary by calling .data. And if we look at it, we can see that it's giving us a dictionary of a couple things. So first are the input IDs. So these are the actual indices into the vocab for the tokens. In the case of BERT, it's also giving us token type IDs. And that is because BERT was trained on a next sentence prediction task. So you had 2 sentences come in, and the token type IDs would be 0 for the first sentence tokens and then 1 for the second sentence tokens. So it's a way to differ for the model to know, to be able to differentiate between the 2 sentences. And then we'll talk about this a little bit more, but there's an attention mask. And this is the key capability of the transformer architecture, is the ability to, as it learns to represent each token, to look at other tokens to help it learn that representation. And the attention mask is essentially a way, if it's 1, to saying, yes, pay attention to those tokens. If there's a 0, let's say there's a 0 right here, essentially it says, don't pay attention to token 0 when you're trying to figure out how to represent these other tokens. Ignore that one. And if we look at that vocab that I was just talking about, here's what it looks like. I just picked out the first 5 tokens. So there's the token, there's the ID. So if hey was up here, we would actually see token 16164 in the input IDs right there. And once with those IDs, we can actually decode them. And you can see that a couple of other special tokens have been added to the text by the BERT tokenizer. There's a class token and a SEP token. And these are used by the model, right? And if you want to look and so when you actually decode the input IDs, it's going to include those special tokens. And these will vary depending on what architecture you're actually using. And we can also look at the actual tokens that that the IDs represent. And so for most tokenizers, you're going to see something like this, and you're going to see characters like this, because most tokenizers use something called subword tokenization. And so by keeping they keep a relatively small vocab, which is important to model performance. And they also eliminate a lot of unknown tokens, which is bad, right? Because if you have tokens in there that are unknown, you can't really learn anything. And so it breaks things up into subwords for kind of rare words, and very common words get their own token, like name's a common word. Wade, especially with my spelling, is not common. So it breaks it up with way, and then 2 hashtags in DE. So that's how the tokenizer works. Now, in terms of the pipeline, we can do a bunch of things with the models in the Hugging Face Model Hub. And just real quick, if you go to huggingface.co and go to models, this is the hub right here. We're doing text classification, so you can click on that to filter by text classification. You can click one of these models, and it's going to give you a bunch of information about how it was trained, for example. Even through the inference API, you can actually test it out right here. And if you find a model that's trained for exactly what you're doing, you can actually just click on here, using transformers, and copy and paste this code, and you'll have everything you need in terms of the tokenizer and model. And probably the biggest thing to keep in mind is that when you're using the pipeline, these things aren't fine-tuned on your particular task. So if you're using a model that's predicting 2 labels for sentiment, maybe positive or negative, and you're trying to train that on the toxicity of multi-label problem, those models aren't going to work with the pipeline. You would actually have to fine-tune that model on your particular task. And that's something we'll look at in week 3. But you can see it's pretty easy to actually just put the task, the raw text, and get results for it. And then if you're interested, you can also look at, what is the model being used here. So you can see we just put sentiment analysis, right? If we look at the classifier.model name or path, we can actually see that the architecture or the checkpoint being used is the distilled BERT base uncase fine-tuned SST2 English architecture. And so if you're curious of what's being used. And as a side note, these distilled versions of BERT or Roberta are simply smaller versions of the original architecture. So they're faster and they only suffer minimal performance reduction. So depending on your constraints, like GPU or time constraints, these might be a really good option for experimentation. You might want to look at the distilled versions of BERT or Roberta or whatever. And then also through the course, you learn that you can also say, yeah, I want this task, but let's say there's a specific model you want to use. So like here, let's say I want to use this German sentiment BERT model that this user right here created. And you can go ahead and run that. I don't know a lot of German, but I know that is good. And we can see that, yes, that's a positive statement right there. And so you can actually go to the model hub, find a model that you want to work with, and use that instead of the default version that we saw above. There's also models for zero-shot classification. And these are really interesting models where we actually, in addition to saying we actually supply the labels, and it can still figure out like, whether or not it's one of these labels, even though we're defining these on the fly. I don't know a lot about how these particular models are trained. It definitely seems like a little bit of black magic, but as an example, we can pass in some text and tell it, hey, these are the labels we're interested in, and it will try to infer whether this is about education, politics, and or business. And you can see here's our labels and here's our scores. It got it right and classified this as being education. And then again, using that .model, .name path, we can actually see what model Hugging Face is defaulting to for the pipeline API. And then always fun is the text generation. And so this is where you're going to supply a prompt, and then it's going to generate text for you. It's going to continue. So here we start with, in this course, we will teach you how to, and we will teach you how to get started using Docker as a tool to manage and whatever. Obviously, this is wrong. That's one of the dangers with text generation, but it is kind of interesting to see, what it actually produces. So you have that pipeline available to you as well. And also there's a variety. You can see like I'm not passing anything in here in terms of controlling the text generation, but there's a bunch of parameters you can pass into that. And so you can see here, we're doing text generation. We're using the distilled version of GPT-2. And I'm passing in a max length and also saying, hey, give me the two most likely predictions. And for a really good understanding of those particular parameters, make sure you check out this article from Hugging Face on how to generate. They go over all the different parameters, how they work, when you might want to use one over the other. So check that out, because there's a lot more to text generation than it may seem on the surface. And then of course we got language modeling. So for like mass language modeling, we're saying predict. Basically, it's like a fill in the blank type of thing. And so here I'm returning a couple examples right here. So all about blank models, about mathematical models, computational models, and it gives you the score. Here I'm looking at the top two. And then we also have, I mentioned text classification, and this is covered in the course. But if you pass in grouped entities, remember when we saw the tokenization of my name, it had WAY was one token, and then ## DE was another token. And when we do named entity recognition, we'd rather it just say Wade is a person's name, not Way and ## and DE is a person's name. And grouped entities takes those subtokens and puts them back together. So it reconstructs the original full word. And so you can see like it's predicted using this model that Sylvan is a person's name, Hugging Face is an organization, and Brooklyn is a location. If you want to see what group entities equals false does, this is actually just how a lot of times I code and learn things. I just change the values and see what happens. You can see that Sylvan's name is actually broken up into S, ##YL, ##VA, ##IN, and they all have I person. And what the group entities basically did is just say, no, that's really just Sylvan. Put those all together and said that's a person. So that's what the group entities does. Question answering. If we supply a question and a context, it should pull out the answer within that text. So the answer is right here. And we can see that it actually does this with pretty high confidence. So about 70%. And it says this is where the start token is, this is where the end token is. That's extractive QA. Summarization is pretty straightforward. Take a big text document, summarize it in 1 or 2 sentences. And then we also have translation tasks, which is also pretty straightforward. You're going to translate from one language to another. So here we're using Marian MT model and going from French to English. And then we can see that this is the translation right here. This course is produced by Hugging Face. So again, the course kind of goes through these a little bit more detail, but are there any questions so far on using the pipeline API or tokenization?
There's one question on tokenization by Ritobrata. So he's asking how to gain the wisdom of which kind of tokenization to use for a particular architecture or data set. So for example, you should be using subword for German Finnish and character level for Mandarin. But beyond that, how do you decide what to use?
Well, so each architecture has basically their tokenization format they're using. And so you're really forced to use whatever that architecture is using. And you don't want to deviate because then you're not able to use models that were pre-trained using that particular type of tokenization strategy. So probably the best thing to do is to look at the documentation. If you go to resources and you can look at the tokenizers doc, and you can get more information about different strategies. If you look at the transformers documentation, you can actually see details about each of the architecture's tokenizers, and you'll be able to discover, like, are they multilingual capable? How many languages were they trained on? Things like that. So that would probably give you the guidance you need.
Yeah, the docs are amazing. There are a few questions around the links. So after the study group is over, whenever the email goes out, we'll make sure the collab and all of the links are there. So make sure you join the fastai Discord and you can check out the notebook.
Yep.
One more question. I wish to include my labels or categories in a named entity recognition model. Any guidance or pointers for that?
So yeah, you can actually create your own labels. And then what you could do is start with one of the pre-trained models that was maybe trained on a subset. Like a real common one is, I think it's the German Cole NNL or something data set. I forget what it is. And you could start with even a data set. For example, I have one model, an NER model that I trained. I started with the German data set and I fine-tuned it on English. And it was amazing how good it turned out. And so in week 3, we'll spend more time going through, like, picking a pre-trained model and fine-tuning it. But absolutely, you can go ahead and fine-tune it for your own labels, even if the labels in the pre-trained model are different.
And I'd just like to nudge everyone towards, writing about this or just publishing your notebooks. Use fast pages or any blog that you want. I'm sure Wade will talk about this, but at least I can speak for Wade and I. All of this creates amazing career opportunities for you as well. So make sure you learn and also write about what you learn.
Yeah, absolutely. I think Perul did something on weights and biases last week, and that's really kind of how she got started. I think she works at Weights and Biases. I'm not 100% sure.
Parul
But
works at H2O.ai along with me.
oh, she does. She works at, okay. Yeah, H2O,
Yeah.
H2O.ai. But she, I think, really kind of got started and her career exploded because she was blogging and then also giving lectures and things and whatnot. And so even stuff like this, when you teach people, and I think this is something that we've all learned from Jeremy Howard, is that when you, wherever you're at, you have learned something that someone is, that you can teach someone behind you that hasn't had that content yet, even if you're just starting out. And a great way to develop your own understanding and also help others is to blog about it, or to do things like this, to do little Zoom sessions and study groups and teach others. So yeah, that's great advice. Anything else?
No questions. No other
All
questions.
right. All right. All right. So let's go back to the presentation here. So we've gone through the pipeline API. We've also seen how we can go to the Hugging Face Model Hub and use the inference API there right on the web, which is really cool. So transformers. So the big thing in section 1 is really like, how do transformers work? What does the architecture look like? And you're not going to have a complete understanding just by going through this study group or by going through the course. I'm going to have some links to some papers and to some articles that you want to read, but understanding how the transformer architecture works, the initial transformer architecture, everything you see as a transformer model in Hugging Face is based on it. So if you want to understand like how it works, you need to understand the transformer architecture. And essentially, all transformer models have been trained as language models. So a language model, and the reason why this is key is that a language model is essentially, you're either trying to predict the next word given a word and its preceding words, like in the causal language model, or you have a mass language model where you got text and you're trying to figure out what these mass tokens or corrupted tokens really should refer to. And the idea of a language model is that if you can build a model that does either one of these tasks really well, then you've created a model that understands the particular grammar of the text that it's seeing. And a model that understands, has a good understanding of the text, is a model that you can then apply to downstream tasks related to that text. So it's figuring out sentiment or figuring out entities or figuring out answers in there. And so that's why language modeling is so critical. And all these transformers and other architectures like ULM-FIT and LSTMs, why they're all based on language models, is because they start with that intuitive idea that, yeah, if I have a model that can do this really well and predict the next token or predict mass tokens, that I have something that understands the particular grammar, the particular language that it's trained on. So that's the whole idea. And so you take these language models, and a lot of them have been trained on a lot of text, on a lot of GPUs or TPUs over many days at a lot of cost, things that at least I can't do with my 1080 Ti GPU and my little DL rig here at the house. And so these folks have pre-trained these big models, and we can take what they've learned, the weights that it's learned through that process, and we can go ahead and grab those models, and through a process called transfer learning, we could take those pre-trained language models and fine-tune them on our particular text. And that's really where this comes in handy. If you're going through the FastAI course or about to, you'll see that transfer learning is the thing in FastAI, because most folks just don't have the ability to go through billions of Wikipedia articles and spend tens or hundreds of thousands of dollars in compute costs to build these things. But fortunately, big companies like Microsoft, OpenAI, and whatnot, they've actually done that for us, and we can use those models on our own, on our limited resources for our particular raw text and for our particular constraints. So how do transformers work? So at a high level, there's two parts. There's an encoder part that our inputs are going to come through. And this part right here is optimized to acquire understanding from the input. And then there is this, and also it converts text to numerical representations. So essentially, each token is going to get an embedding, which is a higher dimensional numerical representation that's going to be learned. So we're going to learn a high dimensional representation for every single token. And they go through a couple layers, and probably the most important is the self-attention layer, which we'll look at in a second. And what it outputs is a high-level representation of those inputs. Then what it does, and remember that the transformer architecture was originally built to handle translation. And so the inputs would be, for example, German text, and the outputs would be English text, so the English translation. So that's what happens in the encoder. The decoder during training, we will actually feed in the correct tokens, but we use something in mass language model called a mass self-attention mask to make sure that tokens can't look at subsequent tokens for building a representation of itself. And we'll take a look at that as well, a little bit more detail. But here, the encoder is focused on understanding the input. The decoder is really focused on generating the output. So generating a high-level representation of that output that we can use for predicting the next text, and then also for things like being able to generate a classification prediction. Now, the biggest thing that I already mentioned is this idea of attention. And essentially, there's 3 different types of attention layers in the original transformer architecture. And a high-level definition would be that this layer will tell the model to pay specific attention to certain words in the sentence you passed it, and more or less ignore others when dealing with the representation of each word. A word by itself has a meaning, but that meaning is deeply affected by the context, which can be any other word or words before or after the word being studied. And so this is actually pretty intuitive, right? That when we're looking at a sentence, the meaning of each word in that sentence is going to be affected to one degree or another by words around it. And so this is an example from Jay Alamar's The Illustrated Transformer article. And the animal didn't cross the street because it was too tired. And he asked the question, what does it in this sentence refer to? Is it referring to the street, or is it referring to the animal? And as we read this, it's pretty simple, right? We can understand what it means, but a model is, computers are pretty dumb. So by using this thing called attention, we can have it when it's encoding a representation for it. It can actually learn to pay attention to the right word, such as animal. Whoops. A little too far there. And so that's the whole idea of how attention works. It's basically allowing us to look at words around each other word to develop a representation of it so that we can understand a word's meaning in context. And this is what the original transformer architecture looks like. And this will also be part of the homework for those who choose to do it, is to actually read these papers. You might be intimidated and think, oh, I'm not going to be able to understand any of this. I guarantee it. You will be able to understand the attention is all you need. And I've read it probably several times. I still go back and look at it because it's really informative about not just the transformer architecture, but how to apply it to different tasks. So this will also be included in the slide deck that we send out to everybody. And if you're confused at all by any of the concepts in the paper, read it alongside the Illustrated Transformer by Jay. And he's got all kinds of great animations and graphics that explain in detail how attention works. And literally probably my favorite resource in terms of, actually all his stuff is really good. He's got illustrated guides to the to Transformer, to BERT, a bunch of stuff. Great resource just to keep that in mind. So the transformer architecture, as I said, there's really 3 types of attention. And right here, don't worry so much right now what multi-head attention means, but here we have bidirectional attention. And so when it's encoding the inputs, the attention layer is allowed to look at the preceding and subsequent tokens and figuring out a representation for each token that's passed through. On the decoder side, we have mass attention. And as I said before, the idea there is to keep in mind is that there's a mask. And remember, we saw that attention mask when we looked at the tokenizer, it produces that attention mask. Well, here, there's an attention mask, and it essentially ensures that as we are looking during training, and we're looking at our target text that we're trying to replicate in the form of predictions, it's essentially masking subsequent words. So it's not able to look at that, because when we do inference, it's going to generate one word at a time. So it's going to generate word one, and then it's going to try to predict two from word one. Then having word two predicted, it's going to try to predict word three from word one and two. So when we're training, we have to mask those future words out. And then the third form of self-attention is encoder attention. So we're actually going to take the representations of each of the tokens that are learned on the encoder side, and we're going to let the decoder learn how to pay attention to those outputs as well. And those are really, so they're all using a form of attention. There's three of them. And so that's really the key concept that has made transformers super popular. So when we go look at Hugging Face, we'll see that some transformers are just encoder models. So they're just actually, any questions coming up yet, Sanya?
This is a follow-up question from earlier. So for the tokenization strategy, they were asking about if they're working on a novel architecture, which approach should they use for tokenization?
For tokenization, I'm not sure how to answer that. If they're working for a novel approach, yeah, I don't really know. I don't know what the best answer to that would be. I would say post that on the Hugging Face forums, and which are staffed by all the ML engineers over there, and see what they say in terms of starting out.
Apart from that, we're just sharing resources and just talking about different blog posts around understanding attention and transformers.
Yeah, anything else, or is that a question?
No, that's it.
Okay. All right. So when you look at transformer models, or you're looking at the transformers library, I should say, you'll see that some are encoder only. So they just include that encoder part that we looked at right here. So they just include this part. Others are decoder specific, and there's other ones that are sequence to sequence that include both. And just real briefly, I'll include here's some examples of encoder only ones. And what I've had really good success with Roberta. If you're just looking to start something out, try the Roberta architecture or the distilled version. But essentially, these are really good for natural language understanding tasks. So if your task is sequence classification, token classification, extractive QA, a mass language model, and you're looking to narrow down your options, think about starting with an encoder model and seeing how that works. Decoder models, again, which is this part right here, focus on text generation. So if you're looking to do something like just generating dynamic text, there's decoder only models you might want to pay attention to. Probably the most famous is GPT and GPT-2. And then a third type of transformer are sequence to sequence models, which really follow the transformer architecture as a whole. They use the encoder and decoder. And these are good where you have tasks where the input length is independent of the output length. So, when you translate, a lot of times you might have 5 English words, but it may only be 3 German words, right? And so they're not going to be the same. And it's also good to use where the output is highly dependent on the input. And so this is good for tasks like summarization, right? Where you have a big article and you want to accurately summarize in a sentence or two, or in translation, or also in generative QA, where instead of extracting the answer, we're asking the model to actually just generate the answer. And that's what that is. That's the difference there. And in terms of sequence to sequence models, I've had really good success on summarization using BART and I think Pegasus. And then on translation, the Marion MT models have proven to be really well if you're looking for architectures to start out with. Any question on any of those three forms of transformers?
No, I don't see anything yet.
And then the last part of this section is bias and limitations. It's just something to be aware of when you're building models, especially when you're using pre-trained models that others have made, is that more than likely there's going to be some form of bias in the data as a result, or in the model based on the data it was trained on, or even the metric it was optimized for. And if you look at the model hub, a lot of these models will actually have that as something they include, which is really nice, right? Because in terms of mitigating negative effects of this, knowledge is probably 80% of it. You have that information, you can make your end users aware of it, etc. If you're looking for more information about how basically where bias comes from and also other mitigation strategies, Rachel does a really good job in chapter 3 of Fastbook to going into this in more detail. So feel free to check that out as another resource. And any questions on any of the material? Because that's pretty much it for section 1.
So there's a question around, is zero-shot learning just encoder, or is it an encoder-decoder model?
I'll say that again, Sanyam. I didn't hear all that.
Sorry. So is zero-shot learning just using an encoder model, or is it an encoder-decoder model?
Let's take a look here. Okay, let's see. Did I actually pull that up there? Okay, tokenizer. So it's actually using the sequence to sequence. So it's using BART for that particular task. And so you'll see that even these sequence to sequence models like BART, they actually are, there's checkpoints available for classification tasks. And I'm not exactly sure, they might actually discard parts. I'm not actually sure how they use the decoder in those particular architectures, but those can be used on classification tasks. And they either probably alter the head of the decoder, is my guess. And they're actually really good too. So I've actually used BART for classification tasks, got really great results on that as well. So again, when you look at these pipeline API, if you, after building it, do .model name or path, you can see the architecture or the checkpoint that the pipeline model is based on. And then if you go to the Hugging Face Transformers docs, look up BART, and you can see exactly how that works. You can actually see the code for the different checkpoints and to see really what's going on.
Awesome. So the next question is, most language model use next prediction as their objective. How do you come up with an objective like mass language models? Any intuition behind that?
Yeah, so you probably another paper to start with if you want to kind of learn different strategies and how that works is, in terms of mass language models, BERT probably is the most famous and kind of the foundation for everything. And they take an approach of dynamically masking every batch, 15% of the tokens, and a certain percent are replaced with the mask token. Another percent is replaced with just a wrong token. And then another percentage actually keeps the same token. And they do that so that the model doesn't learn to cheat in terms of how it actually figures things out. And so if you read this paper, you'll see they've explored other strategies and why they went with that and why it turned out to be pretty successful. There's also it's the T5 paper by Google. They actually explore a variety of different masking strategies and what worked well for their the T5 architecture. So there's different things you can do. You can mask tokens, you can mask words, you can mask like phrases, parts of the sentence. You can flip things around. You can do all kinds of things to add noise for the model to figure out like how to handle it. So the T5 has a lot of example implementations, but I would start with the BERT paper to kind of learn more, since that's where it all kind of started.
Awesome. So there was a question way earlier on YouTube around researches going on in lost languages and how we're restoring them. I'll take this one because I've interviewed someone from this. There's a dialect in Japanese, I believe it's called Kuzu Shiji, and Taran has been doing some amazing research, and there's a Kaggle competition as well on this. So it's about using OCR to really restore these older dialects of Japanese, which I believe no one speaks today. So it's called KUZUSHIJI. You can look that up. Anything to add there? Wait.
I'm glad I didn't have to pronounce that. So. Yeah,
Yeah, no other
I don't
questions.
really know too much about that, but that sounds like a really kind of interesting application of these things for sure.
Awesome. No other questions that I see right now.
Okay. So with that, here's some homework. Read the Attention is All You Need paper. I guarantee it. You can read it. If you got questions, hit up the Discord. Like I said, there's plenty of people smarter than me that are willing to answer those questions. You can also look at the BERT paper that I just mentioned. There's the illustrated BERT, Elmo, and Co., or How NLP Cracked Transfer Learning from Jay Alomar, that has a lot of nice animations and graphics that help explain that paper. And then as a third piece is I mentioned 3 of the fastai Hugging Face libraries. Take a look at those, find one, start playing with it or I'd take a look at all 3 of them and find which one fits kind of your style of coding. They're similar, but there's also some differences. So check those out and kind of get a feel for like, what, which one you like working with based on its syntax, design decisions, and then see if you can build a basic classification model. And if you look at the docs for all of them, you'll find examples on how to do that. And that's it. Unless there's any final questions here.
I think most of them are being answered. So I'll just take a second to wrap up and just appreciate this study group. Really, like I've not enjoyed university so much because it's so boring, and like this makes it so much fun. It's almost midnight in India. Wade has sunlight there. I see Ricardo in the call. He also has some daylight. Matteo is taking notes. He has his headlight on. So it's really this global classroom that we're joining really. And please do interact with people. That's what makes this fun. Make sure you join the fastai Discord. Make sure you join the Hugging Face forums. Tag us, ask questions, discuss as much as you want. That's why we're really doing this. I'm sure Wade enjoys this. That's why he does this. And please join me in thanking Wade and Weights and Biases for helping us host these.
Yeah, thank you everybody for coming. Yeah, it's really a lot of fun for me. Like I definitely, my passion is learning, and there's no way to develop your understanding of things, more so than teaching and things like this. And I appreciate Sonia and you handling all the chat and logistics, so I can just focus on the easy stuff. And I appreciate everybody for coming, regardless of time zone. And yeah, thank you.
Awesome. Thanks, everyone. We'll see you next week at the same time.